Let's do the oxidation and reduction reactions in details. We'll take some example first and then we'll discuss. Let's take copper oxide plus hydrogen giving you copper plus water. Now let's define the oxidation and reduction. Copper oxide plus hydrogen gives you copper plus water. Now what is oxidation? Oxidation, as we all know, is addition of oxygen, removal of hydrogen, and reduction is addition of hydrogen and removal of oxygen. Now here you see copper oxide is converted into copper, which means removal of oxygen has taken place. So what is it? Reduction. So reduction is taking place over here. Now hydrogen has been converted into water, in which addition of oxygen is taking place, which is nothing but oxidation. So we can say oxidation is taking place over here. In other words, we can say that copper oxide has undergone reduction and hydrogen oxidation. This is how we are going to identify oxidation and reduction in an equation. Similarly, let's take a few more examples, like zinc oxide plus carbon. Zinc oxide plus carbon, it will give you zinc plus carbon monoxide. Now from zinc oxide to zinc, it is removal of oxygen, hence it is reduction. Carbon to carbon monoxide is oxidation. If you have manganese oxide plus HCl, 4HCl, giving you manganese chloride plus water plus Cl2. In this also you can see from manganese oxygen is removed, so it is undergoing reduction, and HCl is undergoing oxidation. So over here, in any reaction you see, you will find oxidation and reduction taking place simultaneously, which means that only oxidation reaction is not possible and only reduction reaction is not possible. You will have oxidation and reduction taking place simultaneously. That is the reason why these reactions are called as redox reactions. How these redox reactions happen in our day-to-day lives. Let's take an example. Corrosion. So what happens if you take a iron, any substance which is made up of iron, and throw it somewhere in a very dumpy area where water is there, moisture is there, and temperature is there, air is also there, then in that case you will see that a brown color substance is formed on the surface of that iron piece or iron container or anything that you have taken. So what is that brown color substance which is getting formed? That is nothing but iron oxide. So we can say iron is getting oxidized. So oxidation and reduction reaction is taking place in the presence of water, temperature and air. Iron reacts with the oxygen of the air in the presence of water. Without water and air, this is not possible. Corrosion is not going to take place. So that is the reason why we need air and water both for this corrosion to occur. So corrosion is nothing but when iron gets oxidized to iron oxide. This iron oxide is a brown color solid. So it forms a coating over it. Now again, if you leave any food material overnight, food left outside the refrigerator overnight, next day you try to inhale the smell of it, you'll get a very bad smell and we say that the food is spoiled. So what exactly has happened, when you have left it overnight, the food material has reacted with the oxygen in the atmosphere and it is oxidized. And after oxidation, some kind of substances called as carboxylic acids or alcohols, they are formed, due to which the smell is very bad and the food tastes sour also. If you taste it, you can't eat that one, so you just throw it out. So that is called rancidity. The spoiled food or the spoiling of the food is known as rancidity. So again over here also this reduction reactions are taking place. So redox reactions are everywhere around us in our day-to-day lives. Also we see in all these examples that redox reactions are taking place. So these are very important type of reactions. I hope you have understood what are the reduction and oxidation reactions and why these are called as redox reactions as well. Thank you.